All right, so let's just go back to grade 7 where you started learning exponents. If I were to tell you that I had 2 to the power of 3, what does that mean in an expanded way? Like, what would this be expanded? Yes? 2 times 2 times 2. Great. That's what this little 3 means. So we've got the base, and we've got the exponent. And the exponent tells us how many times to multiply the base. What if I had 4 to the power of 2, so 4 squared, times 3 to the power of 4? What does this mean? Means 4 times 4 times, that dot means a times. Now they could have done it with this dot. They could have also used 2 sets of brackets to show multiplication. And they could have also used, in the olden days when we were doing integers, a times. So what does it mean? It means 4 times 4 times 3 times 3 times 3 times 3. So far, this makes sense? We would take our calculator, 4 times 4 times 3 times 3 times 3 times 3, and if you knew how to use your exponents on the calculator, you would do it that way. What if I have 3 to the power of 2 times 3 to the power of 5? If I were to expand this, I would get 3 times 3 times 3 times 3 times 3 times 3 times 3. Actually, how many 3's do I have? 7 3's. What can you notice about the exponents? What can I do to the exponents? What would be the law of exponents when I'm multiplying? You can add the exponents to make this 3 to the power of 7. So what do I need? How come it didn't work here? How come I could not add 2 plus 4 and say 6?
Because they're all different numbers?
Because the bases are different. When the bases are the same, you can add your exponents, and that would be the law of exponents. So now I'm going to apply that to algebra. So if I have x to the power of 3 times x to the power of 2, what do I actually have?
X to the power of 5.
Very good. X to the power of 5. Because they're saying that whatever this x is, it's the same number. And since we're multiplying, I actually have x times x times x and another x times x, which means that all I have to do is add 3 plus 2 is 5. So let's do a couple of examples. So what if I had x squared times 4x squared? What do I actually get from x squared times 4x squared? Remember, because the bases are the same, what can I do with the exponents? So it's 4x to the power of 4. The law is telling me that since my bases of x are the same, I can easily add my 2 exponents. If I had negative 3x, I apologize, this pen ran out. Negative 3x, open brackets, 6x to the power of 2, plus 5x cubed. What do you think I'm going to get. Now I can't add these, right? Why can't I add these? Why can I not add these together? Yes? They're different. The exponents are different. So I'm not allowed to add these. But we could multiply and distribute this way. Let's see if you got the lesson. What would be the distribution with this? This means negative 3x times 6x squared. Well, the law is saying that I could add this 1 plus this 2. Just like you did here, 2 plus 2, you made it 4. Well, in this case, I do negative 3 times 6, which gave me negative 18. And how many x's do I have? 1 plus 2 is 3. Now, I couldn't do it here because this is an addition. You cannot add them. But when multiplying, the laws of exponents tell you you could add your exponents. So here now, when I multiply this here, I'm going to have negative 3 times 5, negative 15. And I can add my exponents to the power of 4. Are these like terms? No, because this is to the power of 3 and this is to the power of 4. And so they are different terms. It's a binomial, which I distributed by using the laws of exponent when multiplying exponents. Okay, so I'm going to say it again because it was a really good question. The difference between adding 5x squared plus 10x squared, because I'm adding, I'm gathering like terms, I'm allowed to say I have 5 plus 10, I have 10x squared. I do not add these because this is not a multiplication. Had that been a multiplication, so let's say I had 5x squared times 10x squared. Now we're doing the laws of exponent, which says when I multiply, I can add my exponents. Because this actually means x times x, and this means x times x, so we have 4 x's. So I'm doing 5 times 10 is 50. 50x to the power of 4. Very different when I'm adding exponents rather than multiplying exponents. So we'll do one more example. One more example. So let's say I had a negative 8yx squared times, because I'm going to distribute, 3y squared minus 10x cubed. So the laws of exponent are saying that when multiplying, I just add the exponents. When there is no exponent, we need to assume it's a 1. So don't forget this little 1 here. Multiply negative 8 times 3 gives me negative 24. How many y's do I have? Y to the power of 3. How many x's do I have? X squared, because this guy didn't have anything to multiply with. So that's how you start off. All I did was add the 1 plus the 2 to make it 3. That's what the law of exponent said. And now I'm going to do negative 8 times negative 10 gives me a positive 80. I only have 1 y. And how many x's? X to the 5th. I can actually add these two to the 5th. Can these be combined? Can I add these? Are they the same? Can I gather them? Can I simplify them? No way, Jose. The only way that I would be able to add them together is if I had y to the 3 here and x to the 5. They have to have the same exponent for us to be able to simplify them. They are not, therefore there is 2 terms, binomial, coefficient of -24, a coefficient of 80, exponents of 3, 2, 1, and 5. And if I asked you for the degree, what would you tell me the degree was for this? Yeah? 10, 3, 4, 5, 6. Don't forget the invisible one. There are 11 for degrees. Okay, so we just finished the laws of exponents with the multiplication, which was basically adding the 2 exponents together if you're multiplying. And now we're going to do the laws of division. And I spelled division wrong, so division, the laws of division. So if I had 5x to the 6 divided by 5x to the 3, who can guess, and just some kind of guessing on your part after what we just did, what would we do to the exponents here? I would subtract 2. Very good. That would have been my guess. So with the multiplication, I added, and with the division, I'm going to subtract my 2 exponents. Now, how does that look? Well, it really looks like, okay, 5 is always going to be 5, because that's, and it would be x times x times x times x times x, 1, 2, 3, 4, 5 times x. I have 6, and over here, I'm going to have my coefficient of 5, and I have 3 x's. 1, 2, 3. What actually happens in division is x divided by x cancels out. So it's like 1 divided by 1, or 4, you know, it's the 4. If this was a 4, well, 4 divided by 4 would equal to 1. So you actually cancel these out, and you're left with 3 of them. So that's why it's 5 divided by 5 equals 1, and I have x to the power of 3. Let's try another one. 24 x to the 6 over 6x to the 2, or x squared. My final answer here would be 24 divided by 6 is 4. And since my bases are both x's, I can use the law of exponents to subtract 6 minus 2, x to the power of 4. Not bad. Pretty easy. All right, so this is a fairly difficult one. Actually, you know what I'm going to, okay. So this is going to end up being what? A fraction? Because if it was 48 divided by 6, you'd put 8, but it's not. So what's negative divided by a negative is a positive. But 6 divided by 48, what is that? 6 goes 1/8? Does this make sense to you, 1/8? If I just reduce 6 over 48, it becomes 1/8. Now, if you did it in decimal form, you would have done 6 divided by 48, you would have got a decimal. No, you would not get 8. 48 divided by 6 is 8, but 6 divided by 48 is a decimal. So let's leave it in a fraction form. All I did was reduce it. And what would I do with this? This number and the invisible 1 here. What would you do with those? Subtract. So 2 minus 1 means that I'm left with x to the power of 1. I don't need to put the power of 1 because we just assume that it's 1. Y, I would have y to the 5. Good. What did we do? We subtracted 12 minus 7. And do we have any z's? No. 1 minus 1 is 0, so you cannot put 0 z. You just do not put the z. This would be your final answer to this question.